right, Unit 7. Unit 7 has to do with geometric relationships. So go ahead and turn to your front page, the front cover there in your notebook. You see a whole bunch of diagrams of regular polygons. What does it mean to be a regular polygon?
They're all equal sides, not all equal sides, but the sides are all equal.
Yeah, so within each polygon, the sides and angles are equal. Okay? So in that triangle, that's an equilateral triangle. What's a regular quadrilateral called? A regular four-sided figure?
A square.
A square. Nice. Okay, pentagon, hexagon, they all have equal angles. Now, not all pentagons have 5 equal angles, but if it does, it's called a regular pentagon. Same with all the other polygons. Flip to page 3 in your notebook. And we're just going to take some notes there. And the notes are boxed, and then under each section of notes, there are some examples, and we're going to do a couple of those things together, okay? So, classifying triangles. Classification is just a way of naming things. So classifying triangles means you can call a specific triangle a name based on its characteristics. So the first one, we have a triangle that has no equal sides, no equal angles. Any idea?
Isosceles.
Nope.
Equal, no.
Non-equilateral.
What's it called? Isosceles,
Mm-hmm.
Vertebrae or something like that?
vertebrae.
This is
Something that equals 180.
this is a scalene triangle. Scalene triangle. In your next image,
Is that the first one?
That's isosceles.
you have 2 equal sides, 2 equal angles, and you are correct. That is isosceles. Check the spelling on that. And your last one has 3 equal sides, 3 equal angles. It is called an equilateral triangle. Now, if you look at my images, you might say, hey, Mr. B, your second one is the exact same as your third one. And I'd say, well, it doesn't matter. Obey the symbols on the diagram. Okay? Don't look at what you think it looks like. The symbols tell you what it is. Does that make sense? There is no indication that this angle is the same as these two. And there's no indication that this side is the same as these ones. Okay? Obey the symbols on the diagram. Good. Another way, so we can classify them by their sides and angles. Okay? We can also classify them based on again, their angles. What's that first one called? Yep, it's an acute triangle. Okay, that's an acute triangle. What about the next one?
Right.
It's a right triangle. You know that because it has one right angle. Hey, could a triangle ever have more than one right angle? No, because then it would just, yeah, it wouldn't be a closed figure. Good, and the last one has an obtuse angle. It's an obtuse.
That wasn't very nice.
Obtuse triangle.
An obese triangle.
Okay? Good. So, we can classify them again by their side lengths. That's scalene, isosceles, equilateral. Or we can classify them by their angles. Acute, right, obtuse. Look at problem number 1 there. We're going to classify each of those triangles using side lengths. So A has 2 side lengths that are 3 meters and 1 side length that's 2 meters. So by isosceles,
What do we write
you
here?
can just go ahead and write the answer right there.
Did you also write acute, or do you want?
We're just identifying based on side lengths. But yes, that isosceles triangle is also an acute triangle. What about B?
It's scalene.
Scalene. Question 2. Classify each triangle in 2 ways using angle measures. So using angle measures.
The one is acute.
A is acute. What else can we say about it?
It's equilateral.
It's equilateral. Good. And B,
Obtuse.
it is, well, yeah, it looks
That's
like,
acute. Not obtuse.
Oh,
Obtuse is like
oh,
that.
so yeah, yeah.
It's a
No, it's
2B.
No.
2B is definitely obtuse.
The top part.
That yep.
Yeah,
One.
but you only
If it
need
has
angle,
one obtuse,
angle.
if it has one obtuse angle, then the triangle is obtuse. It couldn't possibly have more than one obtuse angle because then it would not be a closed figure. Okay, it would just be Okay, and what else is true about this guy?
It is a triangle.
He's
Skating
Also
or
isosceles.
If you have like a really fat or really skinny diamond.
Okay, so that's when we're talking about triangles. Now we can also talk about figures that have more than 3 sides. What are those called?
Polygons.
Polygon. It's your first blank. So a polygon is a closed figure. That means that all its sides touch. Okay? Doesn't matter what you make it look like, as long as there's no gaps, it's a polygon. This is not a polygon. Okay? It's not even like a closed figure. It's not a shape. Good. It's a closed figure formed by 3 or more line segments. Why 3 or more? Well, 2 line segments could never close a shape. It would just be a line. Okay? Next. What kind of polygon has all sides equal and all angles equal? A square is an example of this kind of polygon.
It's called a geo.
Regular.
What is circle? Irregular.
A circle is not a polygon. So
But
it is a
it's
geometric
elements.
figure, but it's not a polygon because a polygon is a closed figure formed by 3 or more lines. Okay, regular polygon has all sides and all angles equal. Some quadrilaterals have special names. Read along with, please. A regular quadrilateral, 4 sides, is a square. An irregular quadrilateral might be a rectangle, a rhombus, a parallelogram, or a trapezoid. Let's fill in the table first. So you have a table there that says number of sides, and you've got 3, 4, 5, 6. What's the name of a 3-sided figure? Triangle. What's the name of a 4-sided figure?
rectangle.
Every 4-sided figure is a square?
Quadrilateral.
Quadrilateral. Is every 4-sided figure a rectangle? No. Every 4-sided figure is a quadrilateral. 4 sides. That's what that literally means. 4 lines.
A trapezoid.
5. What is a 5-sided
pentagon.
figure called? Penta, meaning 5. Pentagon. And good. Hexagon. Do you know what a 6 or a 7-sided figure is called?
Septagon.
Septagon or heptagon, depending on which language you go with.
Heptagon.
What about 8-sided? Octagon. What about a 9-sided?
Nonagon.
Nonagon. 10-sided?
Pentagon.
Decagon.
Decagon. Good.
Isn't it like dodecagon?
Dodecagon.
All right. You're doing great. Let's label all those shapes. This shape is missing its name. What is this shape called? Ah, thank you. Rhombus.
I like this unit.
Shapes are just so easy.
And this guy is missing his.
Also,
Rhombus.
no?
It has, give you a hint, it has 2 sets, 2 pairs of parallel lines.
Trapezoid.
Rectangle. Quadrilateral.
Parallelogram.
Parallelogram. If you need help spelling parallelogram, it's got a double L in there.
Just
2 parallel lines.
Parallelogram.
Yeah, parallelogram. Excellent. And the last image
Trapezoid.
is called a trapezoid.
Oh.
You may also see that called a trapeze. It's trapezoid.
It's right there.
Okay. Good.
Yeah. It's like the center stone.
So let's look at our problems there. And on the next page, you're using your notes from that block in order to answer question 3 and 4. So question 3A says classify each polygon, stick with it guys, classify each polygon according to its number of sides and whether it is regular or irregular. So A, what is it based on its number of sides? Triangle, quadrilateral, pentagon, hexagon. It's a pentagon. Is it a regular pentagon?
Yes.
All sides and angles are.
No,
Oh,
it's
okay.
an
It
irregular.
is an irregular pentagon. Thank you. B. What do we have there? Go ahead and count the sides.
Oh, yeah, it is a hexagon.
Can we confirm that?
Yes.
6 sides?
We have
Hexagon, regular or irregular?
regular.
It is a regular hexagon. Now, the photocopy is a little squished. Does it look regular? No, it looks a little squished. But how do we know it's
The
regular?
angles are all
The
the
lines on the thing.
Obey
is
the
the same.
symbols of the diagram, okay? If it tells you that all the angles are equal, then all the angles are
Even if
equal,
it's
no
squished.
matter what it looks like. Okay? If all the sides tell you that they're equal, then they're equal, no matter how poorly drawn the diagram is. Okay. 4A, stick with it, my window friends. Classify each quadrilateral and give reasons for your answer. So don't yell them out. Go ahead and look at 4A.
Irregular.
Don't yell anything out, and you don't need to tell if it's regular or irregular because we know they're all quadrilaterals. They're not regular quadrilaterals, but they do have special names. So figure out the name of shape A, figure A, and determine a reason why in your brain. Put your thumb up if you have a response. Jenna.
The first one is a parallelogram. It's a D. I don't know.
Not
It's a
discriminate.
shape.
It's
They
an
don't-
X.
they don't have
It's
genders.
Okay.
All right, why is it a parallelogram?
Sucker.
Because the sides, they have the little symbols. They're equal.
Two
Two are equal and then
pairs of parallel lines. Why is it not a rhombus? Because that's true of a rhombus as well, right?
because a rhombus is no equal sides.
A rhombus has equal length sides. Okay, so this one does not have, this has non-equal side lengths.
Why are we reading that?
You'll figure it out.
I will figure it out.
And for 4B, think about it, don't call it out. We want the name of that shape. And a reason why. Thumb up on your desk if you're ready to go. Do the thinking, don't let others think for you. Jaden.
It's a rhombus.
Rhombus? How do you know?
Because all the sides are equal, and it's a quadrilateral.
For equal side lengths? Well, why isn't it a square?
Because it's not
Because-
perfectly straight.
The rhombus doesn't have 4 equal sides.
Yeah.
Look, I'm here.
Non-equal
Yes, it does.
angles.
Look at this side.
The angles, it means by the
Non-equal angles. Okay? So when you're giving a reason for what you're calling it, make sure that you're quite specific. Make sure that you've ruled out the other options for what it could have been named or other shapes. So we said, yeah, it's a parallelogram. Well, why isn't it a rhombus? We had to think. It's got non-equal side lengths. Rhombus, why isn't it a square? Last little section of notes is on angle properties. Okay, so try and fill in the blanks in your mind. When two lines intersect, the opposite angles are equal. Opposite angles are equal. That's this diagram right here. A,
True and false
A,
motion right
B,
there.
B. Yeah. Opposite angles are equal. Good. And the next diagram, the sum of the interior angles of a triangle is
180.
180 degrees. What if it's an isosceles triangle? Still true?
360.
What if it's equilateral?
60.
180.
Wait, what?
No, it's always 180.
They're always 180.
It can't be 60. That means it's
I didn't know that.
Any triangle in the whole world, the sum of interior angles. That means adding all the interior angles up. It's going to be 180, okay? These is all things that you should know already. Next blanks. When a transversal, so transversal is a line that cuts across two other lines. When a transversal crosses parallel lines, so you have two parallel lines and one line cutting through them, many pairs of angles are related. What is that first set called with the zigzag there?
Oh, we learned about this.
You have learned about this.
The Z and the Y and the W.
Yeah, we learned about the Z thing.
These are called
No, you did it wrong.
No, you
did it wrong.
I did?
Yeah.
Oh, yes, you did.
these are
There's
called
a big difference between
alternate
Oh.
alternate angles.
Yeah, that was one mistake.
Alternate angles. Yep.
Oh, it was C, F, and Z. Or Z.
Yep. What are these guys called in the F?
Corresponding. Actually?
Actually,
So funny.
corresponding. Nice. So alternate are the same. Corresponding are the same. And what is true about those last ones? They're not the same. These are called
Efficient.
co-interior.
You said.
Co-interior angles, and they have a sum of 180 degrees. Okay, so they are supplementary angles in a way. They add up to 180. And you can kind of see that, right? This one is obtuse, this one is acute, and they add up to 180. Good. Let's put that into practice at number 5. Number 5A. Don't call it out. Find the measure of the third angle in each triangle. Find the measure of the third angle in each triangle. So we're finding the measure of angle Z.
That's weird.
Equals 50.
Oh, wow, you shout it out for everybody.
Yeah.
Huh?
We're supposed. Sorry.
Yeah.
I didn't see a hand.
So thanks everybody. So algebraically, I'll do it algebraically. Of course, you can just do it quick on your calculator. But basically what we're saying, we're looking for angle Z. So I'm going to group x plus y, and I'm going to subtract that from both sides. Okay, that's going to tell me that angle Z is 180 minus whatever x plus y was. Okay? So if x plus y is, what is it, 58 plus 72, so that's 130, then that tells me that angle Z is 50 degrees. Okay?
Yes, sir.
B, we're looking for angle R. Get it, but don't call it out. Jaden, what's the measure of angle R?
55.
Thanks, Maddie. And make sure you're writing your degree symbol there. Now, for this triangle, I only had to do 90 minus 35 because I know that angle Q is a right angle. It's 90 degrees already. 180 minus 90 means there's 90 degrees left to share between the other two angles. Okay? 6. 6 says, find the measures of angles A, B, and C in each diagram, and then give reasons for each answer.
A is the we need to say it.
Let's give everyone a second to think about it. Okay? You have to give reasons, so you're using the words alternate, corresponding, co-interior. So who would like to give us A? Yeah.
A would be 75.
75 degrees. How do we know?
Because it's corresponding alternate.
Alternate, no, opposite. Opposite angles.
Oh, opposite.
So just say opposite angles are equal. Okay, if you need to write a reason, you have to jot it down there. You can't just think about it.
And same with all the other angles.
Let's talk about angle C. What's angle C?
75.
C equals 75. How do you know that?
Because it's corresponding to B, and B is equal to A.
Okay.
alternate.
The alternate.
Alternate.
So C is alternate with the angle that's given. It's also corresponding with angle A. Okay? So it's 75. It's alternate angles are equal. Okay? A little jot note of how you know that. And B,
75.
how do we know that?
Because it's equal to every other number.
Because
It's
it's
opposite of C, which is
Okay, so you can use opposite of C, or you can use corresponding with the angle that was given at 75 degrees.
Everything is equal.
Okay? So this is opposite of C, opposite angles are equal. Okay? Go ahead and look at B. Try and get them on your own with a reason. B, A, 4 degrees. All right. Let's do angle A first. Jacob, what do you got?
40,
How do you know?
because they are. They would be.
Alternate.
So-
They would be corresponding.
Yep, good. Corresponding angles are equal. Angle B,
Also
140.
40. How do we know?
Oh, yeah.
Because they're opposite.
Opposite angles are equal. And angle C, give 140. How do we know?
Because it has to equal 180.
Okay, so it's either supplementary with the angle that's
Or
given,
complementary.
or supplementary with the angle B, or co-interior with angle A. Okay? So I'm going to use supplementary, even though that's not even on your notes. Supplementary angle to B. Or you could write co-interior with A. All right, you have practice problems on the bottom of that page. It's all the ones above we already did together. So you're just looking at page 454, numbers 5 through 16, and 459, 1 through 10.